Here is challenge activity 1.1.1, and this is about categorical versus quantitative variables. So let's start the activity. And the question is a person's weight a quantitative or categorical variable? Now, the easiest way to differentiate between the two is that quantitative variable will always take numeric values. So for example, a person's weight would be numeric, so this is a quantitative variable. Anything else, for example, eye color, is going to be a categorical variable because eye color will not take numeric values. So therefore, the answer to this question from the drop-down is that it is a quantitative variable. So you'll select quantitative and then hit check, and that is the answer. That is the correct answer. Here is challenge activity 1.2.1, and this is about types of graphs. So let's start the activity. And the first question is identify the type of graph that is shown here. And the options here from the drop-down are dot plot and histogram. So the first thing to note is we do not have dots here. We have bars. And a histogram is a plot where we have bars. Y-axis is the frequency, and the bars are right next to each other. So this is a histogram. So I will select histogram here and hit check. And so that is the correct response. Now let's go to the next question. Now the next question here is identify the type of graph shown here. So let's see the options. The options are bar chart, pie chart, or stacked bar chart. So clearly this is not a pie chart. We see bars here. So it's one of these two. Stacked bar chart is a chart where the bars are stacked on top of each other. So we do not have that situation. We have one bar each on the x-axis values here. So this is the correct response here is bar chart. And so we will check it, and that is the correct response. This is challenge activity 1.2.2, and this is about misleading graphs. So let's start the activity. The first question is which of the following bar charts may be misleading and why? So let's look at these two graphs here. In the x-axis, we do not see any differences. In the y-axis, they both start at 0, so that's good. However, notice that this graph here, the maximum is 500, and here it's 200. With the maximum being 200, you can kind of clearly see the differences in the bars here, whereas this here, you can't see those differences very well. And you do not really need a maximum of 500 here because the maximum bar height here tends to be between 150 and 200. And so therefore, this is the misleading graph. So I will select this. And from the drop down, let's see what our options are. Since the vertical axis does not start at 0, the differences between yearly profits is exaggerated. And the second option is the axis is scaled so that the changes look smaller than is accurate. So this is the correct response here. So I will select this and hit check, and that is correct. Now let's go to the next question. So here the question is which of the following pie charts may be misleading and why? So here is the first pie chart and here is the second pie chart. So let's go over this. So here we have social media action from 200 users, and this is social media profile status. And we can see that the slices are labeled here, and the slices contain the percentage representation of each of these labels. Now the problem with this pie chart is that the percentages are not adding up to 100, whereas this here adds up to 100. So this is the misleading chart. So I'm going to select graph 1, and from the drop down we can see that one of the options is the pie chart does not add up to 100%. So I will select this and hit check, and that is the correct response. This is challenge activity 1.3.1, and this is about spreadsheets, formulas, and functions. So let's hit start, and the first prompt says set B9 equal to 9. So with B9, what we mean is column B and row 9. So here, column B is here and row 9 is here. So here, if I click this cell, I will just set it equal to 9. So I will just type 9 and hit check. And so that is the correct response. And now let's go on to the next question. Here it says set B1 equal to A7 by using a formula. And the hint is that the formula starts with equal sign. So set B1, column B, row 1, so that's this, and we need to set it equal to A7. So what I'm going to do is I'm going to say equal A7. And what that means is I'm setting this equal to column A, row 7, which is here. So the value is 480. So if I hit this, I get 480. That's exactly what I expected. And if I hit check, that is the correct response. Next question is set B1 equal to A1 minus A2 by using a formula. And this time there's no hint. So first let's look at B1. So again, column B, row 1 is here. And whenever we're entering formulas, we always need to enter the equal sign. And now I can just simply type it out. So I will say A1 minus A2. So that was the prompt. And what this will do is it will take the value here in A1, which is 25, and it will subtract from it the value contained in A2, which is 445. And so that's minus 420. If I hit check, that is the correct response. The next question is use the sum function to set A4 equal to the sum of A1 to A3. Okay. And so this, we first need to set cell A4, which is column A, row 4. So this one right here, this is where we need to enter the formula. So I'm going to set this equal. So again, the formula always starts with equal. I will type sum, parentheses, and then I can type A1 colon A3, which basically means that I'm taking everything, all rows in column A from 1 to 3. Okay, so that's row 1, 2, and 3. If I hit enter, I get 1044, hit check, and that is the correct response. And now the last question is use the count function to set F1 to the count of A1 to A3. So this is where we need to enter the formula F1. Now, if we count this, we have 5 values. So we need to get an answer of 5. So let's click here. Formula starts with equal sign, and I will type count, parentheses. I will type A1 colon E1. And this time the colon basically means I'm counting columns here. So I'm counting how many columns are here from A to E that contain a value. So if I hit enter, I get the answer 5. If I hit check, that is the correct response. This is challenge activity 1.3.2, tables and spreadsheets. So let's start. And the question is, what value is in cell C2? If no value, type empty. So cell C2 is column C, row 2. So this is column C, and the row 2 is here. So the value contained is 48. And if you have to enter the value in any row in column D or any column in row 5, then that would be, the response would be empty because there are no values in those cells. But here we have 48 in cell C2. So 48, let's check this, and that is the correct response. Let's go to the next one. How many cells have values? So we have 4 columns and 5 rows. So the total number of cells is 20. And we have 1 column where we have no value at all. And so therefore we have 15 cells with some values. And that is the correct response. What are the next 3 values if a user drags the autofill square down 3 cells? And so the autofill square will attempt to apply the same pattern that it sees in the selection. And so we can see that row 2 is the next row from row 1, and row 2 equals 21 plus 1. Row 3 equals 22 plus 2. And so therefore row 4 will be 23 plus 1, which is 24. Row 5 will be 24 plus 1, 25. And row 6 will be 25 plus 1, 26. And that is the correct response. Here we have what are the next three values if a user drags the autofill square to the right. And so the similar logic will apply. So let's see, we go from cell A1 to B1, and the difference here is 20. And that same difference gets applied here. So this cell D1 would be 170 minus 20, which is 150. Cell E1 will be 150 minus 20, which is 130. And then cell F1 will be 130 minus 20, which is 110. So hit check, and that is the correct response. And the last question here is, what are the next two values if a user drags the autofill square down the two cells? So we have 4363, 4373, 4383. And so the pattern here is that the numbers here are increasing by 10. So this here would be 4393. And this here will be 4403. And that is the correct response. This is challenge activity 1.4.1. And this is about bias from poor sampling. So let's start. And the question is, for the given situation, determine the most likely type of bias. A survey is taken of a single neighborhood in a town to determine average income per household in the town. So the town has many neighborhoods, but in the survey, we're only surveying one single neighborhood. And then the average income that is determined in that survey is then projected to the average income per household in the town. So the bias here would be due to surveying only a single neighborhood. And so from the drop down, the correct response is under coverage. And if we hit check, and that is the correct response. Let's go to the next question. Determine whether the sampling method used is more likely to overestimate or underestimate the parameter. And the question is to determine whether or not students prefer online courses to live courses. A college has surveyors walk around campus and ask students. And so the problem here is that the survey is being done on campus. And on campus, we expect that most of the students are taking live courses. And so the correct response here is, because we're trying to determine whether they prefer online courses or live courses, we expect that we would overestimate students preferring live courses and underestimate students preferring online courses. So since the question is asking about the preference for online courses, so we would underestimate it, and they check, and that is the correct response. This is challenge activity 1.4.2, and this is about survey sampling. So let's start. And the question is, a sports analyst records the height of 100 players and organizes the result in a histogram. And the question is, the type of statistical analysis is, and from the dropdown we have descriptive and inferential. Now it would have been an inferential study if the analyst was studying a sample of 100 basketball players and say perhaps calculating the average age and then projecting it to the population, which is all NBA players. That is an example of an inferential study. Here we're creating a histogram of the height of 100 basketball players. Creating a histogram to do visualization is a descriptive study. And so that is the correct response. The next question is, a professor with 30 students wants to know the average score on last exam. Should the professor use population or sample? Now in this statement here, the population consists of 30 students in that professor's class. A sample would have been a small sample of those 30 students. So perhaps the professor selects at random 10 students out of the 30. That would be a sample. So what's easy to do here? It's just easy to calculate the average score for all 30 students because the professor has access to them. So the professor should use the population and not the sample. And that is correct. And so now here, last question is, to conduct a survey about the quality of student services, a school selects every 10th student from a list. So this list is an organized list of students in the school, and the school is selecting every 10th student in that list, in that organized list. So what is the sampling method? And here are the options. So this is an example of systematic sampling, because in systematic sampling, you pick every nth student. So it could be every second, it could be every fifth or every 10th. It's an organized list where you pick every nth item in the sample. So this is the correct response. This is challenge activity 1.5.1, and this is about Excel mean and the median. So you have to click this link here to download a spreadsheet, and then the question is about the spreadsheet. And the question says, the spreadsheet linked above contains various housing and economic data for all 50 states. What is the mean of the outstanding mortgage balance for states in the Midwest? So this is the spreadsheet. And first you'll notice that there's a column for region. And so we have regions Midwest, Northeast, South, and West. So we're only looking at the Midwest region. So these are the states that we want to look at. So we want to exclude all of this data when we're calculating the statistic that is required here. So the statistic that we need to calculate is the average outstanding mortgage balance. So you will notice that column D here contains that data, average outstanding mortgage amount, and we only want to calculate it for Midwest. So this is the data that we're going to use to calculate our mean. So I will calculate that here, and I can say equal. Average is a formula for calculating the mean in Excel, parenthesis, and then all I have to do is just select all of this data here. So just select this data. And so the answer is 144,168. So I will go back here and just type this 144,168. And that is the correct response. Now the next question is, what is the median of outstanding mortgage balance for states in the West? So now we want the median outstanding mortgage balance. So that is here, and we are looking at only the West, states in the West. So first, notice that we have, again, the outstanding mortgage amount is this column, and we want to look at states in the West. So that would be this data here. And the column is column D. So this is the range of data that we want to use. All right, so I can calculate that here. I will say equal median, just type out the median, which is a formula in Excel, calculates the median, parentheses, and then for the West, so these are the amounts here. And parentheses again, and the answer is 223,167. So I will type 223,167 and check, and that is the correct response. This is challenge activity 1.5.2, and this is about measures of center. And the first question is, what does the value labeled count represent? So if you look at this table here, there's a value called count, and it's equal to 17. And so if I click this drop down, there are 3 options. And the correct response here is that it represents the number of households that are sampled. So clearly count is not the average number of children per household or the data value that falls in the middle of a sorted data set. So this is the correct response. The next is, what does the value mean represent? So the mean represents the average number of children per household. And then the median is the middle value, the middle value in a sorted data set. So that would be the median. So if I hit check, so that is the correct response. The next question is, in the data set above, which measure of center better represents the data. And the choices are mean, median, or neither. Now, here you can see that the distribution is approximately normal. It's not skewed. And so therefore, the mean can be used to represent this data distribution. And so that is the correct response. If this distribution was skewed, then we would prefer median to represent the center. This is challenge activity 1.6.1, and this is about measures of spread. And the question is, which dataset has the smallest standard deviation? So remember, standard deviation is a measure of variation in the dataset. So if we look at these three distributions, we can clearly see that this distribution here is the most spread out. This is the second most spread out distribution, and this has the least amount of spread in the data. And so the correct response here is that the smallest standard deviation would be for B. So B represents the orange distribution here, and that is the correct response. This challenge activity is 1.6.2, and this is about measures of spread. So we have this graph shown here where the x-axis shows state abbreviations and y-axis is the median home price. And then we have these statistics here. The question is, what is the standard deviation? So if you look at this table here, we have the standard deviation value shown here, and the value for that standard deviation is 113.882. So this would be 113.882. What does the standard deviation represent? So out of the three options here, the spread between maximum and minimum, that's not what the standard deviation is. That is the range. Spread of the middle 50% of the data, that is not standard deviation. The standard deviation is in fact the typical difference between a data value and the mean. So if you look at the formula for standard deviation, you will notice that there is a piece where we calculate the difference between the value and the mean and we square it. So this is the correct response. Next question is, what is the range? The range is shown here. It is 380. So I'll type 380. And then what does the range represent? The range actually represents the spread between the maximum and the minimum data values. And so this would be this answer. And so this is the correct response. Which is a better measure of spread for the data set represented in the computer output? So here's a histogram that we see here and a table again. And we want to know the better measure of spread in this scenario. So let's see the options. The options are interquartile range or standard deviation. Now, because the distribution here is approximately normal, we have a bell-shaped distribution. So standard deviation can be used to get a better measure of the spread. And so that should be the correct response. This is challenge activity 1.6.3, and this is about Excel standard deviation. So again, you're going to download the spreadsheet using this link. And so the question is, the spreadsheet link contains various housing and economic data for all 50 states. What is the standard deviation of average outstanding mortgage amount for states in the South? And so let's look at this here. So the data for states in the South is shown here. So these are all the states in the South. And the mortgage balance, outstanding mortgage amount balance is here. So we're looking at column D. So this is the range of data that we want to use to calculate the standard deviation. Now in this scenario, we're calculating the standard deviation based on the population. So the formula for that in Excel is equal STDEV, and we can see that we have a .p here, STDEV.p, and it says return standard deviation of an entire population. So I will select this, and we're going to select this range of data up until this point here. Okay, and the answer is 388.53 0.583. So 388. 388.53, 0.5831, 0.58. And we're not going to enter 31 because we want to round it to 2 decimal places. And so that is the correct response. The next question is, what is the standard deviation of the average FICO score for all 50 states? And so we want to round that to 2 decimal places. So this time we're calculating the standard deviation of the score here. So that is in column B, and we want to calculate it for all 50 states. So I can type here stdev.p. Again, we're going to use the population-based standard deviation, and let's select the entire range of scores here, right? And this is 16.2776, and that's 4 decimal places, 16.2776. So 16.2776, but we want to round it to 2 decimal places. So to round it to 2 decimal places, this would be 16.28. And that is the correct response. This is challenge activity 1.6.4, and this is about comparing 2 distributions. So the question is, the following histograms show distributions of house prices for areas of a city. You have the north side of the city and the east side of the city. And the question is, check all comparisons that apply. So let's go through them one by one. The distribution for the east has a higher median than the distribution for the north. So median, remember, is the middle value. And if we look at the distribution for east, the middle value tends to be at the peak here. So remember, this is actually an approximately normal distribution or bell-shaped distribution. And so therefore the median would be in the center here somewhere. And since this is, if you notice, at this point, so roughly at about 200,000, you have half of the distribution is on the left side of it, and the other half is on the right side of it. So it splits it into 2 approximately equal halves. And so the median here is going to be around 200,000. But if you look at the distribution for the north, and you look at 200,000 here, you can clearly see that at this point you have a bigger half of the distribution on the left side and a smaller half on the right side. So the median here is actually not 200,000. It would be slightly less than 200,000, so that the 2 halves would then be equal, on the one on the left and the right. So east definitely seems to have a higher median. So I would check mark this. The distribution for the north has approximately the same range as the east. So remember, the range is simply just a difference between the maximum and the minimum value. Now, if we look at the maximum value on the x-axis, it's 281,300 here, and here it's 281,300 as well. And the minimum is 101,120, 101,120. This shows that approximately the range for east and north, they're going to be the same because they have the same maximum values and same minimum values. So this also applies. The distribution for north has only 1 peak. So in fact, the distribution for east has 1 peak, but the distribution in the north is actually has 2 peaks, right? So we can clearly see there's 1 peak here and then 1 peak here. So this does not apply. So if I hit check, this is the correct response. This is challenge activity 1.7.1. This is about box plots and 5-number summary. The question is, the following box plot represents a sample of house prices. So the house prices here are shown in thousands of dollars. And the scale here goes from 90 to 150. And so this scale actually shows house prices in thousands of dollars. So like, for example, 100 here means $100,000. Then there's $110,000 and so on. The question here is, find and interpret the first quartile, Q1. So remember, the first quartile is a value that splits the bottom 25% of the distribution with the top 75% of the distribution. So it represents the 25th percentile. And in the box plot here, this would be where the box actually starts. So the answer here is $120,000. And we can, if we hit this drop down here, so 25% of the house prices fall above Q1. That's not correct. 75% do. The second is 25% of the house prices fall below Q1. That is the correct answer. All right. And then the next question is find and interpret the interquartile range. So remember, the interquartile range is the difference between Q3 and Q1. So third quartile and the first quartile, with the second quartile being the median. The third quartile is where the box ends. And so here we have 140,000. So the difference between 140,000, which is Q3, and 120,000, which is Q1, is the interquartile range. And that difference is $20,000. And the correct response here, let's go through them. The bottom half of the house prices have a spread of the interquartile range. That's not correct. The entire set of house prices has a spread of the interquartile range. That is not correct. The middle 50% of house prices have a spread of the interquartile range. This is the correct response. And this middle 50%, because we are taking the difference between the 75th percentile, which is Q3, and 25th percentile, which is Q1. Given the box plot, complete the 5-number summary and find the outlier. So here we have a box plot. We have the scale shown here. We can clearly see the outlier is here. The first question is, what is the minimum value in this box plot? The minimum value is represented here, and the minimum value, so therefore, is 10. The first quartile is where this box starts. So it is, we have 11, 12, 13 is where the box starts. So 13 is the Q1. The median is this line that's shown here. That is at 15. Third quartile is where the box ends. And that is 16, 17, 18. And the maximum is 20. And the outlier clearly is at 1. So we can see this dot here. So that's 1. Let's check the answer. And so the answers are in fact correct. In this question, we have to identify the box plot that corresponds to the following 5-number summary and outlier. So this is the table shown, and we need to pick which box plot here is the correct choice. So let's look at this. We have a minimum in the table is shown as 22. So clearly choices A and C are incorrect because the minimum there is less than 20. So, and we can see that the minimum for the second box plot is in fact approximately 22. So the correct choice is B. Another way to look at this is the outlier here in the table is 1. The outliers in A and C are actually 70, and an outlier in B is in fact 1. So B is the correct choice here. This challenge activity is 1.8.1, and this is about the shape of a data distribution. So the question is, identify the graph as left skewed, symmetric, or right skewed. So clearly the symmetric graph would be one that would be bell-shaped, and this is not a bell-shaped distribution, so that's symmetric is not the correct answer. So we have left skewed and the right skew. And recall that the left skew is a distribution in which the tail of the distribution is on the left side. So you have outliers on the left side of the distribution. Whereas the right skew is where the tail is on the right side of the distribution. And so therefore the outliers are on the right side of the distribution. In this scenario, we can see that the tail is on the right side of the distribution. The outliers tend to be on the right side here. So the correct answer is that this is right skewed. The next question is, what is the relationship between the mean and the median for the following data? Now, this is not a bell-shaped distribution. If this was a bell-shaped distribution, then the mean and the median are approximately the same. When you have skewed distributions, the mean and the median will be different. Now, median is resistant to outliers. So median tends to usually be closer to the peak. But the mean is not resistant to outliers. So mean actually moves in the direction of outliers. In this scenario, the mean will move to the right side of the distribution because this is a right skewed distribution. The outliers are on the right side here. You can clearly see the right tail. So the mean will be greater than the median because the median will be closer to the peak. And so here, the mean and the median are about the same. That is incorrect. The mean is higher than the median. That is the correct answer. This is challenge activity 1.10.1. So this is about relative frequency bar charts. So let's start. And the question is, adjust the bar heights to create the requested graph by dragging the gray box with 3 lines above each bar. So we need to drag this up to the correct level here. So draw the bar chart for 50% apples. So here, apples will take this up to 50%. Bananas will be up to 40%. And carrots will be, we don't have to drag this because it is already at 10%. So this is the correct response. Let's go to the next one. Draw the bar chart for apple, 3 apples, 2 bananas, and 5 carrots. So first we need to calculate the percentages here. Now there are 10 total values, so clearly if there are 5 carrots, that would be 50%. Then there are 2 bananas, so that would be 20% because that's 2 out of 10. And there are 3 apples, so 30% here. And so that is the correct answer. And now we have draw the bar chart for banana. So here we have scrambled list. So let's see, we have 1, 2, 3, 4, and 5 bananas out of 10. So 5 out of 10 is 50% for bananas. We have 1, 2, 3, and 4 apples. So that would be 40%. And since there is only 1 carrot, that's 1 out of 10. That's 10%. So we don't have to move this. And this is the correct response.